Hello, this is the video number 3 for unit number 4, which is going to be about graphing tangent and cotangent functions. Before you watch this video, you should have your yellow or golden packet and your purple notes for video lessons. Both of those things should be in front of you, and if they're not, please pause the video and come back with them. Okay, now that we are ready to go, let's take a look now at graphing tangent. And so this is the graph that we would like to fill with the curve that's shaped like tangent. In order to do this, notice that we have some values like pi over 2 and pi and 3 pi over 2. So we go back to our unit circle, and we're going to look at those values and figure out what tangent is at each of them. Remember that tangent is sine over cosine, which in terms of the unit circle means that we are looking at y over x. So I'm going to look now at different values of theta, different values of the angle, and compare them with the tangent values at those angles. Okay, so for example, at 0 radians, the tangent is going to be sine over cosine, so 0 divided by 1. So at 0 radians, tangent is 0 over 1, which is 0. Good to go. Then let's look at 45 degrees. 45 degrees, or pi over 4, gives us root 2 over 2 over root 2 over 2. Something divided by itself is going to be 1. So that's the tangent value for that location. Let's do one more, and then we'll swing over to the graph. Right here, we've got pi over 2. And so the tangent value is going to be 1 divided by 0, but that is undefined. That's not a numerical quantity. Okay, so with these values of 0, 1, and undefined, let's come over here to our graph. Okay, so this is where you can start drawing something. 0 had a point of 0, and pi over 2, which is the next tally mark, was undefined. So we show undefined on our graph by showing a gap in the graph. This is going to be a place where tangent doesn't exist. And then we also had pi over 4 had a value of 1. This is what we know so far from our chart, right? 0, 1, undefined. Let's keep going around the unit circle. Over here, our tangent value, sine and cosine are the same except different signs. That would give me a ratio of -1. At 3 pi over 4. 3 pi over 4 is halfway between these next two tick marks. So that would be a point down here. Come over here in the unit circle. At pi, we would have 0 over -1 for tangent, which is 0. So at pi, on the grid, I want to graph 0. Okay, so far looking kind of weird. Then, whoops, went the wrong way. Then here at 5 pi over 4, we have the same number for sine and cosine, and so this is going to give us a tangent value of 1. Same number top and bottom in this sine over cosine ratio. So I have a value of 1. Okay, I'm starting to pick up a pattern because the two dots that I just see over here, I'll emphasize what I mean, these two dots seem like they're like these two dots. And I'm pretty sure that this is going to be a periodic function like sine and cosine both are, just because of going around the unit circle again and again, and things will repeat. So I'm going to just make that cosmic leap here and say that I think there's going to be a break right there, and then there's going to be a low point, and then crossing the x-axis. And we can extend this pattern backwards, like going back to the left, by putting a point here at -1, and then a break, and then the same 3 dots. And then a break, and then more dots, okay? So just with this, we aren't really sure what the shape of tangent is, but fortunately for us, we have done a little work in class. We had some time in the computer lab where we graphed this shape. We graphed the tangent curve in our Excel lab, and so I know from looking at all your graphs that tangent has a shape like this. If we plotted more points, this is what we would see. It's a curve like this. I like to refer to it as right hand up, left hand down. See, the right hand side goes up, and the left hand side of this branch goes down. And then there are a lot of branches like that. just over and over again, because again, it is a periodic function, and a periodic function is a function that repeats itself, same cycle over and over again. So this is the shape we have. So I hope that this is drawn now into your yellow packet, and we are going to put one other shape in your yellow packet. This is our graph of tangent. Oh, I hope you're on the right page. I didn't remember to say that. So this should be on your y equals tangent of x page. And then I would like you to flip to a different page in your yellow packet, the one that says y equals cotangent of x. Okay, well, cotangent looks remarkably like tangent, but also a little bit different. We could get the values from looking back at the unit circle like we did for tangent. And we know that cotangent is the reciprocal of tangent. And so to find cotangent values, cotangent would just be x divided by y. So if I look around here just for a quick second, this point, for example, is a place where cotangent would equal 0, because it would be 0 over 1. And this is another value where cotangent would equal 0. So I have at pi over 2 and at 3 pi over 2. Take a look at this. So at pi over 2 and at 3 pi over 2, cotangent has to equal 0. Well, that kind of suggests, just kind of guessing that cotangent's going to look a little bit like tangent. Here's where our asymptotes are going to be. If you think about the unit circle one more time, these are multiples of pi. Why would cotangent be undefined at these multiples of pi? Well, let's look back. Cotangent would be undefined at multiples of pi because that's these two locations, right here and right here. And I would have x over y. Ooh, x over y. I can't divide by 0. So that's why we have asymptotes in those two spots, or in all those spots. Okay, all those multiples of pi. And then it turns out that cotangent actually is left hand up, right hand down, okay, as compared with tangent. So for each of these branches, I'll put where it crosses the x-axis. And then halfway between an asymptote and this point is what I'm going to be calling a quarter point. So my quarter point's a fourth of the way through the space in between the asymptotes here, is where we have one point that's up and one point that's down. So there's a kind of a midpoint between the two asymptotes, and then these quarter points. Okay, like this. And then cotangent looks like this. It goes through those quarter points. Now notice that the curve itself kind of comes really close to these asymptotes, like this and like this, okay? I don't want to see a graph here. I just need a little space here. I don't want to see a graph where you have the asymptotes like this, and then here's the point in the middle, and then you draw something like that. That's not accurate. The asymptotes really are like scaffolding, and they tell you how wide you should make your graph. Your graph should be way over by the dotted lines, okay? Think of them as like defining the shape. So we need to come way over here and be really close to those asymptotes. Is asymptotes a word you guys know from before? If it isn't, I should write it on here to make sure you know the word, because it's a good vocab word, okay? Asymptotes. That's what those dotted lines are. They're called asymptotes. Okay, so that's the basic shape for cotangent. This distance right here is the A value. Now we don't really refer to that as amplitude with the tangent and cotangent because it's not the distance to a peak, but whatever is in that A slot in the equation is going to determine how tall those quarter points are from the midline. And then another thing that I would like to point out is the period of each of these functions. Notice that this space is one complete cycle of tangent. How wide is that? It's just pi. So the period of this function is just pi. How about for tangent? Well, tangent goes from here, like this distance, right? This green arrow would represent the width of one cycle, and that's pi over 2 on each side of the axis, which together is pi. So again, the period is just pi. So tangent and cotangent have different periods than the other trig functions we've seen so far. They are based on pi rather than 2 pi. We're going to do 2 more examples, and then you are out of here. Now I want you to flip to your purple packet. These are the two example problems that we will do that are variations on tangent and cotangent. So example 1 in your purple packet. Okay, we're going to graph y equals tangent of 2x. We have to determine if that 2 is an a, b, c, or d value. And what I'm thinking of is just like we did with tangent and with sine and cosine, I mean. Right, this sort of thing still is in our thinking. Now it says tangent instead of sine or cosine, but otherwise same kind of idea, okay? So that 2, what kind of value is it? I hope you thought it was a b value because that's what it is. So b is equal to 2. Now something that's going to be different with tangent is our period equation. Period with sine and cosine was 2 pi over b. The over b is still going to be there. But because tangent and cotangent are based off of pi, not 2 pi, that's what our equation is for period with tangent or with cotangent. Okay? So in this case, that would mean that the period is pi over 2. So this is going to be a really squished in graph, okay? It's going to have an even more narrow cycle. Tangent, if you go back to a yellow picture, looks like this, okay? Tangent goes through the origin. That is going to be the case even when it's squished in. We want to squish it in to have half of the length, half of the period. So this asymptote has to move in, and this asymptote has to move in, so that we have like an asymptote here and an asymptote here. Okay, I'm going to take that off the picture because I don't want to keep it that way. But that is what we're going to draw on our purple graph. Oh boy, this is a lot of undoing. Come on, buddy. All right, there we go. All right, so back to the purple graph. Half of the width. So it's going to still cross here, but instead of having asymptotes at the next tick mark, it's going to be half of the cycle. That's what that dividing by 2 did. It made it half of the cycle. Okay, so those are our first 2 asymptotes. Now, halfway between the intercept on the midline and like this point and this point, halfway between those is what I'm going to call the quarter point marks. And our amplitude here is just 1. So from this quarter point, I'm going to go up 1 and down 1. You might say, well, how did you know which side to go up on and which side to go down on? Well, that's based off of the fact that this is tangent, and tangent is right hand up, unless there's some sort of a reflection or something. We'll get to that later. Okay? So here's one cycle of tangent. If I needed to repeat this, I would just look at the spacing and I would repeat the spacing. So the next asymptote would be right here. And my next intercept would be here, and I would look for my quarter points, and I would draw in the graph. Oops. I would try to make sure I connected the dots well. Sorry. There we go. Something along those lines. Okay, so there's one more example, and then the last example we're going to do is based off of cotangent. Okay, in this one, I'm going to make it a much more complex example. We're going to have y equals 2 cotangent pi over 2 x minus pi over 4. There's a lot in this one, okay? Let's line it up against our general form. And let's identify the pieces that we have, okay? We don't have a d value. We do know that a equals 2. In this case, that's not amplitude so much, but it does have to do with those quarter points. We'll come back to that. B is a half. Now remember that now our period equation doesn't have a 2 in it. It's just pi over b, which would give us 2 pi in this case. So this graph is going to be stretched out wider than cotangent normally is. And then our c value here is pi over 4. And our horizontal shift equation is still going to be c over b. So that's pi over 2 over, pi over 4. Sorry, I was thinking ahead about what I'm going to get. Oh, excuse me. Pi over 4, which is c over b. And then when I multiply by 2 over 1 instead, that ends up giving me 2 pi over 4, which reduces to pi over 2. So our horizontal shift is going to be pi over 2 units to the right, okay? So now I need to think about what cotangent normally looks like. You can look back at your yellow packet. Cotangent normally has, don't draw this, but cotangent normally has, well, I guess you can. You could draw it and then we're going to slide it over. Cotangent normally has an asymptote here, and it normally has an asymptote here. However, because the period is 2 pi, that's going to make the next asymptote be over here and the intercept be here. Okay, so we could draw this right now, or we could draw it and then draw it all together, or we could draw it and then shift it. And I'm a big fan of drawing and then shifting, so let's try that. So I'm ignoring the shift right now. All I'm going to take into account is this period of 2 pi, which I have because I've spread out the asymptotes. And now the quarter points are going to be up 2 and down 2 because of this. So here's halfway in the middle of the period. And so halfway between this big dot and the asymptote is where my quarter point's going to be. I'm going to go up 2 or down 2. So in this case, it's down on this side, up on this side. Can you tell me why I went up and down on the sides that I did? That's right, because cotangent is left hand up, right hand down, unless there's a reflection. Okay, so here's the basic picture. Something along these lines would be my picture. I run into my recording box here, so I'm just going to leave it like that. And I didn't draw it solid because this isn't my final answer. My final answer has to take into account the shift. And so now I'm going to move everything over pi over 2. So my asymptote has to move to here. This other asymptote would actually go off the graph. This big green dot has to move over. This little green dot has to move over. This other little green dot has to move over. Okay, and so one of the branches, and I'm actually going to take the green out of here because I think you guys are new enough to graphing this shape that might be really confusing. Okay, so I'm going to take the green out. Oops, a little green over here. And we're going to have something like this. It goes up and hugs this asymptote, and it comes way down, and it would hug an asymptote that's off the screen. Okay, the asymptotes were, remember, 2 pi units apart. So there'd be another asymptote right here, because the spacing for 2 pi is 1, 2, 3, 4 boxes, right? So I count 1, 2, 3, 4 boxes this way. That would be a way to think about it without having to do a lot of computation or calculation. Just think about how many tick marks, okay? And then I'd have another branch over here. Okay, and then drawing this wide is a little bit hard on such a large scale as my board, but we'll go with that. Okay, so that is the graph that I'd like you to have. Now when you come to class, please show me that you took notes, and we will work on some more of these. Okay, thanks so much.